Hi, good afternoon. So I'm here with Professor Radhakrishna Pillai. So now is the chance for you to ask questions, and we'll see if we can answer the questions that you have for us.
There's a delay, I think.
Meanwhile, maybe we can start with the questions that we've gotten before. One of the questions is, how can we apply the material science to in the industry, where already certain parameters are set for performing the tasks? How is this beneficial for engineers, as most of presentations are research based? Well, this course is supposed to be focusing on research. It is not a basic technology course. So we assume that the student or whoever is following has already taken enough courses in the undergraduate and postgraduate level. So we are covering in this course particularly topics of scientific interest, something that is not yet into the course or in the in a textbook. Help people who want to do more than what is there in the regular curriculum or regular course, and those who are interested in research, wanting to know what are the new developments and so on. And the general question of how do we apply material science to the industry is that material science helps us understand how a material works, and in this case, why concrete functions as it is, and also to make something better. If you want to look at new materials and new types of concretes, in this case, how they function and why they function the way they do is we can understand from insights from a course like this. So we have a question now from Arnab. How do you rate geopolymer concrete towards sustainability? Should more emphasis be given to this concrete? Well, again, it depends. Sustainability depends on a lot of things. It depends on where you are, what are the raw materials, and how much is the energy that goes in. So if we can calculate and compare with some other materials, we'll find out if it's sustainable. Maybe in some cases, yes, it is more sustainable than conventional concrete, but this is something that we'll have to analyze. Sustainability depends on what is the carbon footprint, how much energy is required, where the raw materials are coming from, and all these things have to be calculated. Whether we should give more emphasis or not, there are some applications possible, and possibly there are limitations for this type of concrete. In India, I don't think it is going to be accepted or used in the immediate future in a large scale, because we have limitations on applicability and also the materials available. I hope that answers Arnab's question. So meanwhile, let me see, we have other questions. I'll pass on one question to Professor Pillai. It is about the NOD test. Give us a description of the chloride diffusion test. And it is necessary to hold it on an inclined plane. Why is the test done on an inclined plane?
Yeah, so the node test is actually to determine the migration coefficient of the concrete. And we do that on an inclined plane, mainly to make sure that there is no air bubbles below the concrete. No air bubbles get trapped below the concrete specimen. That's the reason why it is done in an inclined plane. There is no other particular reason. And yeah, the description is I don't know if we had covered this in the class.
I'm not sure if it was
covered. I don't think it was covered in detail, but mainly what you do is you try to apply potential difference between two surfaces of the concrete, and then measure how much current is being transferred. Then based on the current for a particular time, you decide a particular voltage, because for different concretes, it will be different voltages will be suitable. So you have to find out what is that suitable voltage for different type of concrete, then redo the test with that particular voltage, and then you can calculate migration coefficient. Main idea is to get the migration coefficient from which you can estimate the diffusion coefficient of the chloride, which can then be used for service life estimation and comparing the performance of different concrete systems. I think the next one, in case another question is, in case of normal concrete with super plasticizer for M35 grade concrete, in case if the reinforced concrete beam fails or develop crack below 0.0035 strain value for loading 2.5 kilonewton to 15 kilonewton, what does this mean? I didn't understand.
Yeah, this question is not clear. Maybe we'll go on to this thing on how do we avoid shrinkage and thermal cracking. Well, there are different types of shrinkage. There is plastic shrinkage, which happens very early in the concrete, and that is when the concrete is still in the fresh state and there is very high evaporation. And this is avoided best by curing or covering so that the evaporation is not there. Otherwise, also we can have shrinkage reducing admixtures. We can have fibers which help reduce plastic shrinkage cracking. So plastic shrinkage cracking, best way is to eliminate evaporation or the stresses that develop due to shrinkage. In drying shrinkage, basically, we have to make sure again that there is no evaporation. When you have higher strength concrete, generally drying shrinkage is less because we don't have much water and the diffusion is also less. However, in these cases, autogenous shrinkage goes up. And again, the only way is to cure it well, and we can have reinforcement which will reduce the shrinkage also. Carbonation shrinkage is the other mechanism which can be prevented by having a good quality concrete which does not allow carbon dioxide to go in. And there are also anti-carbonation coatings which could be used. There was also a question as how thermal cracking can be reduced. Thermal cracking comes because of the heat that is developed within the concrete. All cement reactions are exothermic. So there is heat buildup. And if it's a massive element and there is not heat dissipating, then the heat builds up and this could lead to thermal cracking. So what we generally say is that the temperature of the concrete inside should not go more than about 70 degrees for the concrete not to crack. And also the gradient between the inside and the outside should not be more than 20 degrees Celsius. So if this is satisfied, generally you should not have thermal cracking. Okay. Then there's a question from Anuj saying, why does exposure of concrete to chloride environment to alternate wetting and drying is critical? So I think the question is it is worse to have alternate wetting and drying than always submerged?
Yes.
Why is it so?
So when when the concrete is exposed to moisture, first wet and then it gets into the dry state, what really happens is after the drying stage, during the next wetting cycle, the more water which contains chlorides will be sucked into the concrete. So this wetting and drying cycle, it actually helps in getting more chlorides into the concrete. Whereas in the case of continuous immersion, you don't have this dry cycle. So for example, if you dry the concrete, what will happen is the moisture will get evaporated, but the chloride which is there in the water, in the concrete, will get stuck within the concrete. It won't move to the move outward. But in the case of continuous immersion, once it is stuck, there is no, how do I explain this? There is no...
Does it diffuse out? Or?
Yeah, it doesn't diffuse out and there is no movement towards the inside. In the case of continuous immersion, or the rate of movement or rate of diffusion towards the inside of the concrete is less as compared to what is happening in the case of wetting and drying. This drying process, basically the wicking action. So when the concrete is dry, all the moisture gets evaporated, only the chlorides are staying back, and in the next wet cycle you get more chloride contaminated water is ingress into the concrete, which carries more chloride. So in the case of continuous immersion, this doesn't happen. So there is no increment. That incremental amount of chlorides will be less in the case of continuous immersion.
Okay. So what I understand is when you have wetting and drying, there is a level of saturation, the chlorides go in, and then when it dries, the chlorides stay there,
back.
the water vapor comes off, and then when you have the next cycle of wetting, there is more chlorides going in, and this chloride which was already there is pushed towards more inside.
So
and this is not happening when it's always wet, right?
Yes.
When it's always submerged, you have only a progressive diffusion, but you don't have this acceleration caused by the cycles of wetting and drying.
And what we have seen is, especially for laboratory, like if you keep a wetting and a wet dry cycle of 2 days wet and 5 days dry, that's much worse than if you go with the 1 week wetting and 1 week drying. It's the drying time is also very important to ingress more chloride into the concrete. Longer the drying period, it's better.
Which transport mechanism is ideal for modeling? Maybe what are the different transport mechanisms that have to be taken into account in modeling when you're looking at chloride ingress?
What usually people use is the chloride diffusion model. Mainly, most of the models are based on Fickian diffusion phenomenon. So the second law of diffusion is what typically people use for modeling chloride diffusion into the concrete.
So the mechanism is basically diffusion.
So if you look in literature, you may even see that people talking about apparent chloride diffusion, because that's what we see, because there are cracks in concrete. So many other mechanisms also happen, but we don't really model them because the governing phenomenon is still the diffusion. So whatever we estimate as diffusion coefficient, it's not the true diffusion coefficient, but apparent diffusion coefficient. So mainly fixed second law of diffusion is what you have to look at.
There's a question from Mohammed. How can we increase the foam concrete strength? Well, foam concrete, as you know, has a lot of air voids, and more air or more porosity will decrease the strength. So one way to increase the concrete strength is to decrease the amount of porosity, but that will also increase the density. So you will lose the advantage of having the foam, which is lightweight, insulation, and so on.
5 to 6%.
We can also have some sort of a modifier to increase the strength of the matrix, but I don't think it will be very easy to go to very high strength foam concrete. Anything else from here? This one.
So another question which we got was, a thin unstable layer of passive or protective film formed on the steel surface protect the steel from further corrosion in typical concretes with high pH. However, carbonation can reduce the pH of concrete and lead to corrosion of embedded steel reinforcement. It's asking for clarification for this. I don't know. Yeah, one clarification is why carbonation reduces the pH of the concrete. So during the carbonation reaction, what essentially is happening is all the hydroxide ions which are present in the concrete is being consumed in the carbonation reaction. So when there is a reduction in the hydroxide ions, you have a reduction in the pH. And when the pH of the concrete is reduced, the steel will not be, it will become more and more vulnerable to corrosion. So that's what happens. I think it clarifies. The next question, in case of cement replaced with supplementary cementitious materials like fly ash, etc., does the mortar test are sufficient to fix the optimum replacement percentage, or is it compulsory to test on concrete? I think we will have to test on concrete, because if you are looking at any transport mechanisms, or how chloride, moisture, or oxygen or carbon dioxide penetrate into the concrete, if you're looking at that, then you definitely need to test it on concrete. If you're looking at something which is corrosion initiation, or something which happens at the interface of the steel and concrete, then maybe you can study using mortar. But there are other issues also which have to be looked at. So the answer is you have to study the concrete.
Why chloride profile
I wanted
sometimes?
to ask why chloride profiles sometimes change with the depth by increasing its content from concrete surface to the inside. The highest content inside rather than outside. How does that happen? What are the factors affecting its penetration in concrete, in garages especially? Yes. So this at the near surface of the concrete, where it is in contact with the solution, or let's say seawater or something, there the chlorides can also move outward because of leaching out. So the near surface, there may be movement of chloride both inward and outward. So that is why you are seeing a lower chloride concentration at the near surface, which may be in typical concrete, you can say 2 to 3 millimeter size thickness. You may see a reduced chloride content than what is a little bit inside. So the answer is there is a movement, outward movement also. That is why you see a reduction in the near surface chloride concentration.
Okay. We have a question about glass fiber reinforced concrete. The glass fiber reinforced concrete is used a lot in panels and architectural applications where we cannot put steel fibers because they'll cause staining on the surface. So sometimes you must have seen on the outside in facade some intricate carving type of structural element or architectural element. So these are made with glass fibers. Sometimes we can use it for interior slabs, like a screed to protect, say, a PT slab. We can use glass fibers. So glass fibers give some amount of protection in the sense that it will reduce cracking. But basically, it is used in applications where you have to reduce, you don't want large cracks, and you do not have very high structural loads also coming on. So that is where we use glass fibers. Then is there any possibility of using sodium hydroxide and sodium silicate in solid or flex form?
Fluid form.
Solid or flex form. Not sure. This is a question from Sanjay, which is not very clear what the question is. Sodium hydroxide and sodium silicate must be activators for geopolymer concrete, but it's not clear what is the question. Then Anuj says, what is the chloride threshold value applicable to Indian environmental conditions?
Chloride threshold value will depend on the type of steel and type of concrete, cement which you use. What we have found is for typical ordinary Portland cement concrete and the TMT steel which we use in India, we can use 0.4% by weight of cement as the chloride threshold. But if you use SCMs like fly ash, we have seen that the chloride threshold will decrease a little bit, but it has a very good positive impact on the diffusion coefficient. Like a diffusion coefficient decreases, so the end effect on service life may still be better for a fly ash based system. So one point to tell here is we should not look at only the chloride threshold. We should look at both chloride threshold and transport properties like diffusion coefficient, and then only we should decide on which material to select for ensuring durability.
So Yuvraj asks whether we should take sulfates and chlorides as critical exposure condition for substructures. Well, we should. If that is going to cause durability problems, we should take it as the critical exposure condition. So it doesn't matter if the superstructure is affected or the substructure. Ideally, what we should do is take every part of the structure and see what is most critical for it, and then see how to protect it, how to reinforce it adequately, or give some surface protection which can help.
Local exposure.
Then there's a question from Mohammed Zulfikaruddin asking, what is the alternative of cement in the future? Well, as far as I know, I've been asked this question many times. I don't see any other material that is going to replace cement or concrete in the future. The cement may look different, the concrete may look different in the future, but at least for a long time to come, I don't think there is an alternative which can replace concrete and replace cement as the binder of the concrete. So what we'll have to do is make sure that the carbon dioxide emission is lower in the cement. We'll also have to make sure that structures last longer. We do construction better so that the overall impact of the carbon dioxide emission is minimum. We have to reduce the CO2 footprint, and we also have to make sure that structures last longer. That's why we worry a lot about durability, that whatever we build should last as long or more than we want it to, so that there is no wastage of material. We do not have to demolish and replace.
Another question which we got is from Paresh Unarkar, RCC consultant. In a performance-based concrete designed for 100 years, what criteria should be defined? Which are the tests to be carried out at laboratory and at site? And how to check and maintain the results? So what criteria should be defined for the steel concrete systems? I would say we can look at, if it is designed for 100 years, we can look at probabilistic service life and what are the parameters like chloride threshold or diffusion coefficient. These two could be the main things which you can look at. And also at the same time, because sometimes chloride diffusion takes time, a long time to determine. So we can also look at other tests like resistivity of the concrete and then RCPT. Resistivity is a good test which you can actually do it at site itself, which can be correlated to the diffusion and other parameters, or the corrosion rate, for example. It's not very easy to correlate, but there are standards available which says if your concrete has a resistivity of less than this much, then you can expect long life. So not quantitatively, but qualitatively, they say that if you get different levels of resistivity, you can actually have better life like that. Then tests to be carried out at laboratory and at site. In laboratory, we can look at various transport properties and corrosion properties. For transport properties, we can say NOR test is one thing which will give you migration coefficient. Then another test is ponding test with chlorides, which can give you ASTM C1556, based on which you can determine the diffusion coefficient. Then oxygen permeability index test, and then water sorptivity test, and then carbonation, accelerated carbonation test. So there are different tests which you can, mainly you have to look at is what is the exposure condition, what is going to be the governing deterioration mechanism, and appropriately decide. So chloride, moisture, oxygen, carbon dioxide, these are the things which we have to worry about, and how to determine how fast these things will get into the concrete, somehow determine that. How to check and maintain the result. I didn't get the meaning of maintain the results.
Probably saying how to keep the records, because you are designing for 100 years. How to keep the records of maybe the structure.
So this is not widely practiced, but what we will request is, or you can suggest is, maybe at the end of 5 years or 10 years, you can go back to the structure and then measure what is the actual diffusion coefficient of the concrete based on the testing on the core, which you can extract from the structure, get the chloride profile, and then actually determine what is actual. Because in the beginning, you do a very well-controlled laboratory test and you may get very good number, which may or may not be reflecting actually on the site. So you can actually do a test maybe after first 5 years, then another 10 years. So you can refine the service life estimation as you move on. So that would be an ideal way of doing it, but very difficult to do.
Well, let me take a couple of other questions. There are a lot of questions coming about durability. So before Professor Pillai continues, let me take a couple of questions from Shubham Raj. He is asking about what happens when you have voids. Is it better to have, in terms of strength, large number of smaller voids, or small number of larger voids? Well, it depends on a lot. Well, if you have very tiny voids which are not very interconnected, sometimes if you have a crack, the crack is actually blunted and the toughness goes up. But in general, all voids will decrease the strength. There is no case where voids can increase the strength. It is only the crack resistance which can change. So from fracture mechanics point of view, if you have a lot of voids near the crack tip, then the crack tip is blunted. But if you have a lot of voids which are interconnected, then the crack goes through very easily. So there is no simple answer. It depends a lot on the cases, and we might have to model it to see what happens. Okay. Then Sundar asks, can you tell about the potential of recycled aggregates as an alternative for conventional fine aggregates, and what will be the cost? Well, we don't know what the cost will be. Certainly, if we can get an alternative to fine aggregates, that's always good, because we are running out of raw materials. We should not be using a lot of natural materials. In concrete, it will be good if we can recycle as much as possible. Then Anuj asks, if wicking action is critical, why do we use apparent diffusion coefficient?
It is critical, but when you talk about apparent diffusion coefficient, most of the time we use the continuous immersion test. So when in ASTM C15, C56, we use continuous immersion, and that from that test we get the apparent diffusion coefficient. In that test, there is no wicking action actually. That is something which happens at the site. So that's the difference there.
Then Kiran asks, I think you have already responded, which parameter is important for service life? Diffusion coefficient or chloride threshold? I think it's clear you have to look at both.
Yeah, you have to look at both. And what we are now finding is, as the base values, so for example, if the chloride diffusion coefficient decreases significantly, then the effect of chloride threshold is not that significant. If the diffusion coefficient, in other words, when a very good quality concrete is used, the chloride threshold may not be that critical. But if you are using actually relatively poor quality concrete, then chloride threshold plays a very significant role. So both are important.
Okay. Vaishnav asks, is it possible to develop materials that enhance stiffness without increasing strength much? Well, I wish I knew. There is, right now we relate stiffness with strength, though in the industry they would like to have a decoupling of strength and stiffness. So we are hoping that some young researcher like you will be able to develop a material where we can change the stiffness without necessarily increasing the strength. Mohammad Zulfikaruddin asks, how can we reduce the dead load of RCC? Well, we have to decrease the RCC dead load by an optimum structural design. If we can use higher strength concrete, then even we know that high strength concrete and normal strength concrete, the unit weight is the same. So if we can go for higher strength concrete, we will have an overall lower dead load. And that is what is happening. That's the reason why we see in high-rise buildings, they are going for higher strength concrete, because overall the dead load comes down. Bharat asks, how can authentical RCP test for concrete at high temperature, because RCPT gets affected by temperature? I guess he's asking, what is the effect of
authentical RCPT test for concrete which are comparatively?
Or I guess he's saying that
actually
RCPT is affected by temperature.
Yeah.
So how do we take the RCPT test?
Actually, if you look at there are instruments where the heat, whatever is the heating happened, the heat is, there are like plates, or somehow we keep the specimen in cold condition or relatively cold. We don't let the specimen get heated. But most of the time when we do test, if you only apply like voltage, then specimen will get heated, and then there will be issues associated with the test result. You won't be able to complete the test. But there are instruments, I think it's called Prove It, where they actually have electronic systems which will actually absorb the heat and don't let the specimen get heated. But another way of doing it is reduce the voltage. But then you will not be able to correlate the classification or the coulombs which are given in standard documents. So that another research which you may have to do, like what is the equivalent amount of coulomb for a lower voltage, when we apply a lower voltage, and if you want to develop test methods. So main thing is you have to keep the specimen, you don't let the specimen get heated. It's very, very important. So you may have to modify your test setup so that it doesn't happen.
Yeah, just like many other tests, we should understand that the RCPT test is basically to compare different concretes. So as long as the concretes are similar, then a change in RCPT really has a meaning. But if the resistivity of the concrete is very different and one concrete is going to behave very differently than the other, it may not have much sense to use the RCPT. But we should understand that tests like this are only a relative measure. The absolute value may not mean much. Can you suggest the most reliable test on corrosion monitoring?
Corrosion monitoring at field. Widely people use half cell potential, but there are also a lot of challenges associated with, again, you're asking a question on reliability. So half cell potential, it's very difficult to actually assess, but world over people use it, sometimes without really knowing what the numbers mean. So we really have to be more careful. And at this moment, I would say, that is still the best test available. But there are instruments available which use, linear polarization resistance technique. But still, it's not very simple to do corrosion testing. You need to know what the steel is, what the moisture condition of the concrete cover is, and how that is going to influence your test measurements. If you don't know that, then you may get just random numbers, which may lead to erroneous conclusions also, which I've seen many reports with such erroneous conclusions. So to the point, if I want to answer your question, I'll still say half cell potential, but with a care on, what the concrete cover is, how wet the concrete cover is. It's all very important. Because that's the easiest testing available to do today. And reliability, anyway, you are not looking at what is the absolute value of the corrosion rate. You are again looking at only what is the probability of corrosion happening. So that will still give you a reliable result, provided you control the cover concrete properties.
Question from Arnab about the accelerated curing of high strength concrete. He says that the standards are not very clear about it. Well, you will have to do some trials and see if it is really going to be useful to get some higher strength by acceleration. Generally, you will, because all reactions in cement can be accelerated by higher temperatures. So there will be some acceleration. But what is the correlation? You will have to do some trials and see. There have been cases where say 50 megapascal concrete has been accelerated also. So it can be done. We will have to calibrate and see how much time is required and what is the strength that you can necessarily get.
Another question from Mr. Bharat Jindal. Is there any correlation between RCPT and direct permeability test? I would say, these are two, RCPT is basically a migration test. And because you are applying current and then taking the measurement, where a direct permeability there's no current involved in it. So there may be some journal papers which may say, I don't know about them, but there is some correlation for that particular experimental set. But I don't know if we can really generalize that. So that's something which we have to really look at. So theoretical correlation may be questionable, but you may find some empirical relationship based on some limited test done in some laboratories.
Question from Paresh Unarkar. He says, there are a lot of concepts about durable concrete, but these things are not followed at the site. How to educate? Well, the first thing is to talk about it. We have to understand that these things are important and educate engineers, educate the owners, and put in the specifications correctly. I think that is the way to do it. So we have been trying to do our best, and if people in industry also realize it, then it will be good. Before structures start falling down. See, generally when people realize it's important is when structures start falling down. And then we find out that it is too late, and then future we do a better job. But if we can learn from others' mistakes and the problems that are there and improve our construction, it will be always good. So it is up to young people to realize that durability is important and see how to educate their colleagues, bring in practices which are good, which will give durability. Our specifications have to be carefully written so that durability is not compromised.
So this everybody says about L1 as the problem, but I think if we do a little bit of homework in the beginning during the design stage itself, then and work on specification, write very clear specifications, then L1 may not be a problem. You will be able to actually produce good quality concrete with minimal cost. It is possible. It's not that, you know, when you go for a more durable concrete, it's always there is not significant increase in the cost. You can actually achieve durable concrete with you know, not much increase in the cost. Actually, there is a myth that when you go for more durable concrete, you really have to invest a lot of money, which is not really true.
So Prabha asks, can you explain how to identify the age of a concrete structure when there are no documents available? Well, I don't know. I don't know if there is any definite way to do it. Maybe if it has some admixture, can we do carbon dating?
It's the only option.
That may be the only option. But again, I don't know. Maybe this is a research topic that Prabha can take up.
What are the challenges? Anuj M. What are the challenges for handling high performance
and UHPC
at site? Fines. So,
well, generally, these are concretes which are have to be handled more carefully because small changes can affect the properties. So you have to do things which are usual for other concretes, but we have to do them more, take care of it in a more strict way. I don't think there's anything very different from normal concrete, but normal concrete probably is more forgiving than HPC. And UHPC, again, at the site, it may be very difficult. Maybe it's a concrete more for prefabrication and making in plants rather than at the site. Any other questions? Well, if there are no other questions, we'll close this session. Thank you for coming online. We hope that you are enjoying the course. Send us comments so that we can see what to do in future courses.
One question came. What kind of material modifications to be done to improve the flexural strength of concrete, especially for pavement systems?
Well, it depends. What do you define by flexural strength? Is it the post-crack strength or just the cracking strength? The cracking strength is like increasing the compressive strength generally increases the flexural strength. But if it's post-cracking, fibers are very good for pavement. So we have done a lot of work on pavements with fibers. Shubham Raj asks, PPC can, according to
IS 10262, PPC be considered equivalent to OPC 43 for design, but still cement companies are producing PPC equivalent to OPC.
See, the standards are very different from OPC and PPC. PPC doesn't have a grade. OPC has a grade. So that is basically the difference. There is no conflict between the standards. PPC only has a single grade, or there is no grade. Then Suraj is asking, explain about the hydration of calcium sulfoaluminate. Well, it would have been explained by Professor Piyush. Probably you will have to go through the lecture again. I'm sure that he has discussed enough about the hydration in the beginning of the lecture. So please check there. Shankar is asking any practical application of geopolymer. Not major applications, but some experimental applications have been done in many places, like SCRC in Taramani has some roads which have been made from geopolymer. And in other places also, wherever they've done research, they have done some work, done some applications of geopolymer. Anything else? Okay, so we'll close. And we'll probably have one more live session. Anusha and the other TAs will inform you. But you keep sending questions and I'm sure our TAs will handle it. Thank you.